nonlinear to linear models. So, nonlinear models can be converted to linear models by applying the following functions. So we could use exponential, logarithmic, trigonometric, or power. And so what we do, if we realize that x and y have an exponential relationship, is we can take that variable x and put it in an exponential function and create a new variable, and then use that new variable in the model to predict y. So, for absolute percentage error, what we're going to use is 1 minus n, the sample size, and the sum of actual minus the forecasted divided by the actual. And that will provide us the absolute percentage error. I should also note that for absolute percentage error, we'll multiply that times 100 to make it a percentage. Now, mean absolute error is a measure of the difference between two continuous variables, and is computed as a sum of, for all variables I through n, we take the absolute value of y minus x divided by n. Mean absolute percentage error, also known as mean absolute percentage deviation, is a measure of prediction accuracy used with trend estimation in statistics. It's generally defined as a percentage, and so we compute it as 100% divided by n multiplied by the sum for all values I through n as the actual value minus the forecasted value divided by the actual value as an absolute value. Lastly, RMSE, or root mean squared error, is frequently used to measure differences between values predicted by a model or an estimator and the values observed. This is often used as another way of measuring accuracy, and is computed as the square root of the mean squared error of the estimator, or computed as the square root of the sum of all values from I through n of y hat minus y squared divided by t for the number of times that a variable has been observed.